Hi, on today's tutorial we are going to explore Wi-Fi microcontrollers. More specifically, we will use the quite popular ESP32 microcontroller to change the mute and unmute button on Teams. Have you ever been on a Teams call, wanted to speak, but found out that you don't know where the unmute button is on the screen? Why not have a physical button that you can click and unmute you? Wouldn't it be even better if you could have this button wirelessly interact with your PC? We are going to create this solution using an ESP32 microcontroller board. You can easily find these boards cheaply on any major retailer online, and they will serve you well to create any Wi-Fi based projects that you might want to do. In this particular project, we will use the TCP/IP network sockets to send this button interaction between the microcontroller and our PC. To do that, we will program the microcontroller using C with the Arduino IDE, and then on the PC side, we will write a Julia script. So, the ESP32 microcontroller is an evolution of the original ESP8266 that took the microcontroller world by storm back in 2014 due to its low price. This chip was incredibly hyped at the time. I do remember reading new articles on blog posts every month praising the device due to its high integration and also a low price. It was such a success in the Wi-Fi microcontroller world that they have released the ESP32 a couple of years later with more memory, better peripherals, and also an updated processor. It since has become the go-to solution for low-cost products that require Wi-Fi due to its low price and also a large community. You can buy these chips for less than $1 and a bit more for a full model. The model solution is quite popular as the chip itself needs to have an external antenna for both Wi-Fi and also Bluetooth. So if a company wants to quickly release a product without the need to design the radio frequency part of it and without bothering with certifications, this is the perfect solution. You can easily program this device using the Arduino IDE. And that's what we are going to do today. We are going to use a basic TCP socket server and use it to communicate through Wi-Fi with the PC. We want that when a user clicks on the physical button that is available on the board, a packet is sent to the PC as a response to the client. On the PC client, we recognize that the button was clicked, and then by simulating the keyboard, we will hit the Teams shortcut to mute and unmute the microphone. This is the board that we are going to use today. The microcontroller itself, the ESP32, is here on this module, fully covered in metal to try to reduce the amount of noise that reaches the most sensitive part of the system, that is the transceiver. The transceiver is then connected to here, this small antenna that works at 2.4 GHz. Then here on the left, we got our serial to USB chip. On the top, our power supply, the USB connector that provides not only data but also power, and then two buttons. The one on top is a reset button, and then the one on the bottom can be user-defined. And this is the button that we are going to use to mute and unmute our microphone. Now we are going to program our microcontroller. We are going to use the Arduino IDE for that purpose. The Arduino IDE was initially made just for Arduino boards, but currently there is a support for a multitude of different boards. For you to set up the Arduino for your specific board, you only go to Boards Manager and then search for your board. In our case, we are doing the ESP32, so we just go over here and install. Currently, I have it already installed, so I don't need to, but it's this one, the one from Express If Systems. After having our board installed, we are going to connect our microcontroller through the USB to our computer. It's going to be identified, and we can go over here and we'll check that it's COM11. So if I unplug it and plug it again, you can see it's this COM11. You go over here to edit board and then select, in our case, the ESP32 board. That should be the dev model. That's it. Okay. So we got everything defined for our specific board, and we are going to start with an example here. So just go to File, Examples, and there is a ton of different examples for the ESP32. We are going to use the one for Wi-Fi, and I guess we can use something simple here. Oh, yeah, simple Wi-Fi server, why not? So here it is, our simple Wi-Fi server. We are going to change a little bit of this code. The first thing that is quite important here is using our SSID. So the name of your hotspot, I'm just going to put here hotspot, then the password as well. Then here on the server, we define the port. 80 is a port usually defined for web pages. I'm just going to put a number here. So it's going to be 1, 2, 3, 4, 5 as our port. I also want to interact with our button to mute and unmute our microphone. And that button is actually the one on pin 0. And instead of being an output, it's going to be an input. This comment, it's no longer relevant here. Then what I want to do is, as soon as that, oh yes, everything that is here is to define a web server on port 80. I'm not going to use that. So I guess I can remove everything from here, I guess. Let me give a look. Okay, so we got an if here. So if we got a client available, so what we have here is a web server. So a TCP server that can accept sockets, as we are going to see next. And as soon as a client is connected and that client is available, I'm going to read what a client sent to me. And I want to respond with my pin status that I'm going to read from my port 0. So this one is our button. And then, of course, I will print back to my client. So client print ln with this pin status as a string. Pin status. So usually the pin status is going to be a boolean. It's either 0 or 1. In my case, I want to send a string. So everything is going to be strings here. And you know what? I think this will work. So I'm going to receive something from my client, if the client is available. And then I'm going to send it back with the print ln, our current pin status. So if the button is pressed or not pressed. This is our code. Let me try to compile it first, see if it works. For that, you just click on this button over here. So it seems like I forgot to put the type. It's a boolean. Let's try it again. And this time it should work. So it seems like it was able to program correctly. Currently, it's just sending the file to the microcontroller and resetting it. And it seems like everything is okay. Now, from the code itself, we can see that the setup part, what it does is begins with a serial here with this baud rate. Then we define our pin mode, our button as an input, the initial, and then you can see there is a lot of information here that is being printed through the serial port. So you can see that if we connect to the serial port on the board, there is tons of information that we can use. So we go over here to Tools, Serial Monitor, yes. Then we select, oh, it's already, COM11. Then the baud rate, it's correct. Currently, I'm just seeing dots, but if I push the reset button on my board, we see that's currently connecting. And here it is. So currently, it's connected to my Wi-Fi, and we have a fixed IP address. We need to save this, as we are going to use later. So we already have our server here, where we can connect a socket to, and start communicating with it. We are going to create now the client, and we are going to use Julia here with the library sockets to create our TCP socket. The first thing that we are going to initialize is going to be our server. So I'm going to connect to the server with IP that I just copied and the port that I've defined, 1, 2, 3, 4, 5. Okay, we have now created our connection to the server. Now, is there any byte available on the server? It's something that I can see here with this function bytes available. No, currently there is no byte available on our received buffer, but if we remember correctly the code from the other side, from the side of the server, we need to send something over there. To do that, we are going to use the function print server, and I'm going to send a question mark. So the question mark has been sent. Another thing that is specific here, we'll not see anything here still on the bytes available. The buffer needs to be refreshed. One function to do that is the end of file. I'll run it once, and now I got 3 bytes available. So let's give a look to the bytes that we got available here by using the function read line. So reading the line of the server, and we'll see that we have received 1 inside of quotes. This means that we got a string over here. If I go over here to my ESP32 and click on the first button, the button that we are going to use, and I try this again, so I'm going to question, end of file, and then read it again, and I got a 0 now because the button is pressed. So we know that we got a 0 if the button is pressed, or 1 if the button is not pressed. Based on this, we can already start writing our code. We are going to create 2 variables, one for the current status. I'm going just to initialize as a 1, and then the previous status. Also the same initialization, 1. Then I'm going to create a loop. This loop, of course, you can put a condition. I'm just doing a quick prototype, so it's just going to be a while true. And if I have any byte available on the buffer, so if this variable is higher than 0, I'm going to read from the buffer on my variable button now. Okay, perfect. If the button now is equal to 0, meaning that it's currently being clicked, and before it was 1, then I know that I've changed the status where the button was not clicked to being clicked. And if this is the case, I'm going to run a command. Now, the command I'm going to write, it's only going to be able to do this on Windows. In other platforms, we need to check how it's done. But what I'm going to do on Windows is just running a PowerShell script that is going to do a system call emulating the keys sent by the keyboard. So it's going to be a system call on Windows. So to run a command for a given operating system, we can use the function run. And I'm going to paste here the command, but I'm going to explain it as well. So this is a PowerShell script. And inside of that PowerShell script, I'm creating an object that is part of the Windows script. And I'm going to use that library to send the following keys. And the keys that I got here is Ctrl, Shift, plus M. Both of these 3 keys are going to be used for the shortcut on Teams. So after this condition, I can end my if statement. I'm going to save on my variable before the current value. And I'm going to have as else sending a question mark to the server to check the current status. Then, to not create a denial of service here, I'm just going to sleep for a little bit, half a second, and then refresh my buffer with my end of file function. and my else statement, and if everything is okay, the code should now be ready to try. So let's give it a look. Okay, so currently it's running. Remember, I'm having here a while loop, so the code is just being run and it's waiting for my input. My input then, it's going to be from the board, clicking on the button. To do that, first, let's go to Microsoft Teams and let's see if the shortcut actually works. So currently, I'm on my Teams call, and here we got the board on the left. As soon as I click the button over here, my microphone over here also changes the status. So you can see that the shortcut, it's Control plus Shift plus M. As soon as I do the button here on the ESP32 board, we simulate that keyboard shortcut in order to trigger microphone off or microphone on. And that's all for today. We'll meet again on the next tutorial.